We're going to be looking at how to find a quadratic equation from a table. How do we tell if a table represents a quadratic? We went over this briefly a while back in class, but you may not remember. If you get a table, you're trying to figure out what kind of function it is. Things to look at are the differences and the ratios. Okay, differences meaning what do I add? If I take this minus this, what do I get? If I take this minus this, what do I get? This minus this. If those are all the same, then the table shows a linear equation. If you look at the ratios, you take this divided by this divided by this divided by this. If those are all the same, then you've got an exponential kind of equation. For a quadratic, we're looking at something a little bit beyond the differences. So if we look at this particular table, we look at the differences. 8 minus 4 shows us that we're increasing by 4 between those two values. Then we take 14 minus 8. There we're increasing by 6. And then we're increasing by 8. And then 10. So if we look at our differences, they're not all the same, but we can see there is a pattern between them. If we take the differences of the differences, also known as the second differences, 6 minus 4 gets us 2. 8 minus 6 gets us 2. 10 minus 8 gets us 2. And if the second differences are all the same, then the function is a quadratic. The second differences are constant. They're all 2. So f of x is quadratic. If the second differences are not constant, f of x is not a quadratic. Now, what do we want to do if we want to write an equation for this function? We figured out that the second differences were 2, so it is a quadratic. So f of x, you can write it as ax squared plus bx plus c. How do we figure out what those things are? Well, it turns out that a is always equal to your second difference divided by 2, no matter what. If it is quadratic, then the value of a is always equal to the second difference divided by 2. In this case, that's 2 over 2, which is 1. So then we know that this function, f of x, is equal to 1 times x squared plus bx plus c. Then we're left with figuring out what b and c are. Now, notice that if we got rid of this x squared, bx plus c is a linear equation. We know how to find the equation. We know how to find the linear equation. So if we want to find b and c, what we can do then is move x squared to the other side of this equation. F of x squared minus x squared. And then we would have a linear equation that's equal to bx plus c. So we can make a third column here that is equal to f of x minus x squared. So from each of these, we subtract x squared. F of x is 4 minus 0 squared is 4. 8 minus 1 squared is going to be 7. 14 minus 2 squared. 2 squared is 4. 14 minus 4 is 10. 22 minus 9 gets us 13. 32 minus 16 gets us 16. Now looking at this right here, we can see, oh, here we do have a common difference. We're adding 3. Right? When we have a linear equation, that common difference is our slope. So in this case, we know our slope, it's bx plus c, so our slope is equal to b, and in this case, that's 3. And this value here that we're adding, that's our y-intercept. We could have looked at that right away, actually. When x equals 0, our y-intercept is going to be 4, so c is equal to 4. So then we figure out that our overall equation for this function, move the x squared minus x squared back to the other side, our original function, the equation is x squared plus 3x plus 4. We can double check. 0 squared plus 3 times 0 is 0 plus 4. 1 squared plus 3 times 1, 1 plus 3 plus 4, that's 8. 2 squared, 4, plus 6 plus 4 is 14, so that works. So one way to figure out the equation of the quadratic, once you figure out it is a quadratic, You find the second differences, divide the second difference by 2, that gets you the value of a in the quadratic. Then move that over to the other side, make a third column that's equal to whatever's done on the left side of your equation, which should leave you with a linear equation right here, and then you can use that to find the values of b and c. Here's another example following the same pattern. We've got x and g of x. If we look at this table, our differences, we go down 1, minus 5. From 6 to negative 3 is minus 9, and then minus 13. So not constant differences, but the differences between the differences, or the second differences, are all negative 4. So our second differences is negative 4. So our value of a is half of that. Negative 4 divided by 2 equals negative 2. So we know g of x equals negative 2 x squared plus bx plus c. And to find b and c, we can make a linear equation by adding g of x, or adding the 2x squared to the other side. So if I take g of x plus 2x squared, I should get something that's linear. So for x equals 0, that's 12 plus 2 times 0 squared, that stays as 12. Then I've got 11 plus 2 times 1 squared, that's 13. 6 plus 2 times 2 squared. 2 squared is 4, times 2 is 8, plus 6, 14. Oh, looks like we're increasing by 1. Negative 3 plus 2 times 3 squared. 3 squared is 9, times 2 is 18, plus negative 3 is 15. Negative 16 plus 2 times 4 squared gets us 16. So this is linear. We can see we're increasing by 1 each time. So if our common difference is 1, that means that b is 1. And our value when x equals 0 is 12, so we can say that c equals 12. So b is 1, c is 12. So in that case, we know that g of x equals negative 2x squared plus 1x plus 12. Here's one final example to look at. Looking at the differences, it is important to keep track of signs. So from 10 to 6, we're going down 4, 6 to 5, we're going down 1, 5 to 7, we're going up 2, 7 to 12, we're going up 5. So we can see from there that our second difference is a positive 3. Our second difference equals 3, which tells us that our value of a in our quadratic is 3 over 2. So h of x equals 3 over 2 x squared plus bx plus c. So if we want to get our b and c by setting up a linear equation, we can subtract 3 over 2 x squared. I'm going to do it in decimal form because I think that's a little bit easier for this case. H of x minus 1.5x squared. Well, 10 minus 0 is 0. Then we have 6 minus 1.5, which is 4.5. We have 5. 2 squared is 4, times 1.5 is 6. 5 minus 6 is negative 1. And we have 3 squared is 9, times 1.5 is 13.5. 7 minus 13.5 is negative 6.5. And 4 squared is 16, times 1.5 is 24. 12 minus 24 is negative 12. Looking at that, this is indeed a linear pattern. We're subtracting 5.5 each time we go to take a step down our table. So that tells us b is minus 5.5. And looking at our y-intercept, we can see that c is 10. So our final equation that we get here, h of x equals, I'll change 3 halves to a decimal, 1.5 x squared minus 5.5x plus 10. So even though we had some fractions, we can make it work and get it done. So that's how we find quadratic equations from tables.